Section 2, it talks about areas in a plane. And as we covered earlier in class, we basically have this general rule. You're going to take the top function minus the bottom function and integrate from whatever limits you would see with those two functions, or whatever the question asks you to integrate between. A couple things to kind of see from this overall rule, a few things that have to be true. First of all, whatever functions we're looking at, they have to be continuous on a closed interval, and you have to have one function that is always larger or bigger than the other function. Or I guess the way that this is phrased, g of x has to be less than f of x the entire time. So you have to make sure those two things are true, but then anytime they say find the area between this region, take the top function minus the bottom function. And I suppose one other thing we should quickly mention, normally it's top minus bottom, but as we'll see in our second example today, sometimes it makes sense to go right minus left. So you might just want to jot those two things down. Right minus left won't make sense. It'll blow your mind when we actually go through that example though. Okay, so we want to find the area of the region that is in between the graphs of x squared plus 2, y equals negative x equals 0, and x equals 1, those four equations. And a lot of times, especially as you're getting used to this, it's going to help to draw a picture first. So, I'm going to zoom in here a little bit, so I have a little bit more room to draw. And you all know what x squared plus 2 looks like. That's going to be a parabola that opens up. We can probably figure out what y equals negative x looks like. So I'm just going to pause for a second, get a drawing. You try to sketch it as well while you stop the video here. So you're just going to have a very informal graph, and it doesn't have to look very pretty. Mine usually don't, but just to kind of clarify, we're looking for the area kind of in here. Okay, that's what we're looking for. So always try to figure out the general area that you're looking for. That's going to help you find your limits and figure out how to draw your rectangle. But I do like step 2 here. Draw just any sort of rectangle in here. It's going to help you figure out how you want to set this up. So that's kind of my rectangle. From that, I know that my width of that rectangle is dx, and then I know that the parabola is the top one, the line is the bottom one, and it just kind of helps me figure out how to lay this thing out. If I see a dx there, I know my limits will have to be x values. Okay, so that being said, step 3 says now use that to help you set up your integral, and let's quickly go ahead and do that. Zoom back over here. Okay, write a few things down here. Okay, so based on what we see in our picture, we want to take the parabola minus the bottom function, the line. You just have to be really careful here because you want minus and then it's a negative x. Our limits would be from 0 to 1 because, like we talked about, we see our width would be dx, so I need to find x values that are the limits for that area or that region that I'm trying to find. And once you have that set up, I would just take the time just to rewrite it and kind of simplify some things. So I put things in order, x squared, and then it becomes plus an x and plus a 2. I still can put my limits right there. And now it's a pretty basic question. Now I just need to find the antiderivative and plug in those limits. So x squared, that antiderivative is 1/3 x cubed. Okay, I'd have a plus 1/2 x squared plus a 2x. Okay, and then I'm going to do the limits from 1 to 0. And as I go through and kind of calculate some of this out, obviously plug in a 0 in for all those pieces. You're just going to get a 0, so I can just kind of ignore that. I'm going to end up with a 1/3 plus a 1/2 plus a 2. And I know how much we like dealing with fractions. Remember, common denominators are good. So our common denominator would be 6 for this. I'm going to have 2/6 plus 3/6 plus 12/6. Add all those up, I would have 17/6, and you would just need to find an answer that would be equivalent to that. So that's a pretty typical example, top minus bottom. Our next one will add just a little bit to that. So if you notice, here we're looking for the area between a region again, but notice how they write the equations. Now things are solved for x. And so you could easily go through, you notice that the second one here is just a line, so I could solve that for y. This one would be a little bit more complicated to solve for y. If you did it, you'd end up with some square root functions. Should have a positive square root and a negative square root function. Putting them together, you get a sideways parabola. So you could definitely go ahead and solve for y and graph them that way. Another option is to maybe make a t-chart. Think about plugging in some different values and figuring out what you would get in return. The difference here is you might be thinking about plugging in potentially some y values and getting the x values. So let's just think about how we might do that. I think we'll start with the line because that's going to be a little bit easier. Okay, and you would just kind of start trying some things, but maybe I'd get a negative 1, I'm sorry, negative 2, a negative 1, 0, 1, and 2, and just kind of see what values I get. If I plug those in, I'm going to get negative 1, 0, 1, 2, and 3. Okay, so we're definitely going to see a pattern there, but those are going to be easy ones to graph. For the sideways parabola, you might just kind of start out, see what you get. So maybe I'll start with a 0, a 1, and a 2. And if I were to plug those in, I would get 3, a 2, and a negative 1. And that's great. That can be helpful. I might just try a few other ones just to get a few more points to graph. So if we try a negative 1 and a negative 2, I'm going to get another 2 and a negative 1 here. Okay, so some of the x values start repeating. But again, just another way of getting this graphed. You just want to have some sort of a picture to help you represent what's going on here. So I'm going to pause the video here, graph these points, get a general picture, a shape of what's going on here, and then we'll continue. Okay, so after I graph those points, I get this kind of a picture. And again, try to figure out what area you're trying to find. It's the area between these two graphs. And so right in here, there's a big chunk of area that is kind of cut off from those two graphs. In this case, it's going to make more sense. I mean, I could do this, what I had done for example 1. I could draw a rectangle going like this. The issue is I would need to have there's two functions here, right? At this point, I have a different top minus bottom than I did for the first one. And that gets a little complicated trying to do it that way. We can talk more about that in class if you so desire here. And of course, my undo function isn't working here, so I can't take those blue things away. But it's going to be easier, perhaps, to draw our rectangles this way. Okay, so that sideways rectangle there. And so in this case, we still want to take the big values minus the little values. We're just going to do this in terms of x. And so the bigger x values are on this side, smaller x values are here. So we're going to take this function, the sideways parabola, minus that function, the line, because that's going to be big minus small. So in this case, notice that for this sideways rectangle, our width of this is not dx anymore, it is dy. And when you see a dy for the width of your rectangle, that means you want to find y values for your limits. So let's go back to our picture, try to find a few coordinates here. The coordinate up here is 2, 1, and the coordinate down here is -1, -2. That's going to tell me the y value limits as I go in this interval here. I want to start with the y value at -2, and I'm going to keep drawing my rectangles in until I get to a y value of 1. So as we set up our integral here, okay, we would have from -2 to 1, those are my y values. The top function, I'm sorry, the function on the right this time is going to be 3 minus y squared minus the left function, which is y plus 1, and I have a dy there. So again, everything is in terms of y for this way. We're just kind of flipping things. Instead of having a vertical rectangular strip, now we're having a horizontal one, and that puts everything in terms of y. So as maybe I rearrange this a little bit, and I could kind of reorder everything that I'm looking at with my functions. I'm going to have a negative y squared, I would have minus a y, and then I'd have a plus 2. So that's a little easier to work with. And then from there, you guys could either do this without a calculator, you could try to do this with a calculator as well. It's in a good form, just enter in your calculator. Your answer should be 4.5, and I think we'll leave that one right there. So this is a little bit more complicated. Again, jot down some questions if you're not quite sure why we're flipping things around. Write down some good questions and we can go over it in class.